Hi everyone, how are you? Hope all are doing fine. So this is Karthik and welcome to our beautiful channel Master, and we are doing the journey with the most beautiful subject EMTL. Okay, so we have started a new topic, that is Smith chart, and we have completed lecture 1 on Smith chart, and this is going to be lecture 2 on Smith chart. Okay. So this is going to be lecture 2 on Smith chart. Okay, so in the last lecture we have stated that our aim is to map all the possible values of load impedances onto the gamma plane within a unit circle. Yes or no? Okay, so in that process we have successfully mapped all the possible values of resistances onto the gamma plane. Okay, so now today we are going to see how to map all the possible values of reactances onto the gamma plane. Understood? Okay, so our aim is to map what here? Our aim is to map all the possible values of resistances and all the possible values of reactances onto the gamma plane. So we have successfully mapped all the possible values of resistances, and now we try to map all the possible values of reactances. So what is the range of reactance here? Minus infinity to plus infinity. What is the range of resistance here? 0 to infinity. Understood? So we have successfully mapped these resistance values. Now in this lecture we try to map all these possible values of reactances onto the gamma plane. Okay, so in the last lecture we have seen that ZL bar, normalized load impedance, and reflection coefficient at load, these are related by this equation. Yes or no? So that is ZL bar is equal to 1 plus gamma L by 1 minus gamma L. Okay, so ZL bar and gamma L are related through this equation. We have seen this in last lecture. Understood? So now here, where ZL bar is nothing but R plus JX, and this gamma L is in general complex quantity, so we have represented the complex quantity as U plus JV. Okay, now substitute that in place of gamma L, substitute U plus JV, so you are going to get 1 plus U plus JV in the numerator, and in the denominator you will get 1 minus U minus JV. Okay, so then we have multiplied and divided with 1 minus U plus JV and 1 minus U plus JV. Okay, so once we have done this simplification, we got real part and imaginary part. Yes or no? Okay, so what is the real part we got here? We got real part as 1 minus U square minus V square by 1 minus U whole square plus V square, and imaginary part we got as J into 2V divided by 1 minus U whole square plus V square. Okay, so this is the expression we got. So this is R plus JX. Then what we have done here? We have equated the real part on both sides. Okay, so that means we have equated the real part on both sides. So we got R is equal to 1 minus U square minus V square by 1 minus U whole square plus V square. So after doing some mathematical simplifications, okay, finally we got an equation. That is U minus R by R plus 1 whole square plus V minus 0 whole square is equal to 1 by R plus 1 whole square. So finally we got this equation. Yes or no? Finally we got this equation. Okay, so here in this equation, for each and every value of resistance, you are going to get one circle. On which this resistance is going to be constant. And hence that circle is called as what here? Constant resistance circle. Yes or no? Okay, so like that, for different values of resistances, we are going to get different constant resistance circles. For different values of resistances, we are going to get different constant resistance circles. Understood? And hence this equation, we can say it represents family of what here? It represents family of constant resistance circles. Okay, so and hence this equation we can say it represents what here? Family of constant resistance circles. Why here? Because for different values of resistances we are going to get what? Different circles on which the resistance value is going to be constant, and hence we call it as what here? Family of constant resistance circles. So I forgot to mention this terminology here in the last lecture, but remember that this equation represents what? Family of constant resistance circles. Understood? Okay, so now, and we have successfully mapped all these family of constant resistance circles onto the gamma plane. So now we try to equate the imaginary part of this equation. Okay, we try to equate the imaginary part of this equation on both sides. Okay, so then what you are going to get here? You will get x is equal to what? X is equal to 2v divided by 1 minus u whole square plus v square. 1 minus u whole square plus v square. Okay, so now I am sending this denominator term to this side and I am expanding this 1 minus u whole square. So then what you are going to get here? What you are going to get? X into, I am sending this denominator to this side and expanding this 1 minus u whole square. So you are going to get u square minus 2u plus 1 plus v square Okay, and I am sending this 2v to LHS side. So you are going to get minus 2v is equal to what? Is equal to 0. Now I am dividing on both sides. With respect to x. So if I divide on both sides with respect to x, what I am going to get here? So instead of writing again one more step, I am writing here itself. Okay, so divide on both sides with respect to x. So here x, here x, here x. Okay, so here x will get cancelled. 0 by x is nothing but 0. Okay, so here you will get minus 2 into v by x. Yes or no? Okay, so you after dividing with x, you are going to get this expression. Okay, you are going to get this expression. Now this u square minus 2u plus 1 plus v square minus 2v by x. So that means 2v into 1 by x. Okay, so now here I am adding 1 by x whole square and subtracting 1 by x whole square. So it doesn't make any difference. Yes or no? I am adding 1 by x whole square and subtracting 1 by x whole square to this equation. Understood? Okay, so now this expression that is v square minus 2v into 1 by x plus 1 by x whole square. So how we can write this one here? We can write this as v minus 1 by x whole square. Yes or no? And this expression here, how you can write? You can write this as u minus 1 whole square plus this expression, we can write it as what? V minus 1 by x whole square. This is equal to, I have sent this minus 1 by x whole square to RHS side. So you will get this is equal to 1 by x whole square. Understood? Okay, so finally we landed up with this equation. Finally we have landed up with this equation. Understood? See, if you observe this equation here, it is almost similar to this equation or not. In this equation, for each value of x, you are going to get what here? You are going to get one circle. On which this reactance value is going to be same. And hence that circle is called as what here? Constant reactance circle. So like that, for different values of x, you are going to get different circles on which the reactance value is going to be constant. And hence we can say this equation, represents what here? Represents family of constant reactance circles. reactance circles. Yes or no here? Yes or no? Why we are calling this as family of constant reactance circles? Because for different values of x, you are going to get different circles on which the reactance value is going to be constant, and hence we call this as what here? Family of constant reactance circle. Okay, so now we try to map all these constant reactance circles onto the gamma plane, Okay, so next we will see how to map all these possible values of reactances onto the gamma plane. Okay, so in order to do that, first I am going to form a table. That consists of three columns here. So in the first column, I am representing reactance, that is x, and in the second column, I am representing center, and in the third column, I am representing radius. Okay, so what is the circle, or what is the center of this equation here? What is the center of this equation? Is nothing but what? What is the center of this circle here? Is nothing but 1 comma 1 by x, and radius is what? 1 by x. So here the center is nothing but 1 comma 1 by x, and radius is 1 by x. Okay, so for different values of x, we are going to get different circles with different centers and different radius. Understood? Okay, so we know the range of x can take the range of x is from minus infinity to plus infinity. So it can take both positive values as well as negative values. So first we try to map all the positive reactances. Onto the gamma plane. Okay, later we will see how to map negative reactances. Okay, so first we will see how to map the positive reactances. So that means here we are considering the range of x as what here? From 0 to infinity. Okay, we are considering only positive values of x here. Okay, later we will see, later we will analyze for negative values of x. Understood? Okay, so this is reactance, center and radius. Okay. So here I am drawing the gamma plane. This is u axis. This is z v axis. Okay, so this is nothing but what? This is nothing but gamma plane. Okay, so okay. Now let us consider x is equal to 0. See, for each value of x, we are going to get one circle. We are going to get one constant reactance circle. Okay, so for x is equal to 0, you are going to get one constant reactance circle, and its center is going to be what? Put x is equal to 0 here. What you are going to get? 1 comma infinity. And put x is equal to 0 here. What you are going to get? Radius is infinity. See here, if you observe the center here, we are having what? 1 comma 1 by x. So that means u coordinate. This is u coordinate and this is v coordinate. Yes or no? This is u coordinate and this is v coordinate. If you observe, u coordinate is not depending upon x. It is a constant value. So even though x varies, this u coordinate is not going to change because it doesn't depend upon x. Okay, so v coordinate is depending upon x. So as x varies, this v coordinate is going to change. So for all the centers here, what you are going to get? U coordinate will remain same and v coordinate is going to change. Understood? And also, if you observe, v coordinate is 1 by x and radius is also 1 by x. So that means whatever the v coordinate we are going to get here, okay, so the same value you are going to get for radius also. Understood? Okay, so keep these things in mind. So now, so we have substituted for x is equal to 0. Next, for x is equal to 1 here, for x is equal to 1, what is the center you are going to get? You are going to get the center as 1 comma 1. And radius is what? Radius is same as v coordinate. So, sorry. So next, substitute the value of x as 1 by 2. Substitute the value of x as 1 by 2. Okay, so then what you are going to get here? So the center you will get 1 comma 2. And radius is what? Radius is 2. Radius must be same as what? The coordinate. Okay, next substitute value of x as 1. Then the center will become 1 comma 1 and its radius will be what? Radius is 1. Okay, next if you substitute 2, you will get 1 comma 1 by 2. 1 comma 1 by 2 and radius is what? 1 by 2. So like that, if you substitute, if you go on increase the x value, you can increase the x value up to what? Up to infinity. So you can go up to infinity. So as x goes to infinity, the center reaches to what? So put x equal to infinity here. What you are going to get? 1 by x will become 0. Yes or no? 1 by x, and put x is equal to infinity, you will get 0. So that is here you will get 1 comma 0. And what is the radius here? Radius will be equal to 0. Understood? Okay. So here for each value of x, you are going to get one circle on the gamma plane. Now we try to draw those circles. On the gamma plane. Okay. So if you observe these centers here, if you observe these centers, u coordinate is for each. If you observe these centers, u coordinate remains same here. U coordinate is 1. Everywhere u coordinate is 1. Okay, only v coordinate is changing. Okay, so if you try to draw the locus of all these centers here, what you are going to get here? You are going to get a straight line. On which u coordinate is 1 and v coordinate is going to change. Yes or no? So that means that straight line must be what? That straight line must be parallel to what? Parallel to imaginary axis. Yes or no? So if you move parallel to imaginary axis here, u coordinate is not going to change, only v coordinate is going to change. Yes or no? Okay, so the locus of all these centers represents a straight line, that is parallel to what? That is parallel to imaginary axis. And on that line, u coordinate must be equal to what? Must be equal to 1. Okay, so I am drawing that line here. I am drawing the locus of all the centers. So let us say this point is 1 comma 0. So u coordinate is 1 and v coordinate is 0. Okay, so if I move, if I form a line, if I draw a line parallel to imaginary axis, then on this line u coordinate is going to be 1. Everywhere u coordinate is going to be 1, but what is going to change here? Only v coordinate is going to change. Understood? Okay, so if we draw the locus of all these centers, you are going to get a straight line that is parallel to imaginary axis like this. Understood? Okay, that is parallel to imaginary axis like this. So now from this table you can make one more observation here. See, for x is equal to 0 circle, the center is what? 1 comma infinity and the radius is what? Infinity. Yes or no? Okay, so see, if you observe the distance from 1 comma infinity to 1 comma 0, the distance from 1 comma infinity to 1 comma 0 is how much here? Is nothing but infinity or not? And radius of this circle is also nothing but what? Infinity. So that means I can say the distance from 1 comma infinity, to 1 comma 0 represents the radius of what? The radius of x is equal to 0 circle. Understood or not? See, if you consider x is equal to 1 by 2 circle here, its center is 1 comma 2 and radius is what? Radius is 2. Now if you observe the distance from 1 comma 2, the distance from 1 comma 2 to 1 comma 0, the distance from the 1 comma 2 to 1 comma 0 is how much here? Is how much? Is nothing but 2 units or not? Okay, so that means I can consider the distance from 1 comma 2 to 1 comma 0 as what? As the radius of x is equal to 1 by 2 circle. So similarly, if you consider x is equal to 1 circle, its center is 1 comma 1 and the distance from 1 comma 1 to 1 comma 0 is nothing but what? 1, and its radius is also 1. Okay, so that means what is the observation we can make from all this means? Okay, so for each and every circle here, the distance from the center of the circle to 1 comma 0 represents the radius of that particular circle. Okay, so that is the observation we can make. So what is the observation we can make here? For each and every circle, what do you mean by circle here? We are talking about constant reactance circles only. Okay, so for each and every circle, the distance measured from the center of the circle to the point 1 comma 0 represents what here? Represents radius of that particular circle. Will represent what here? Will represent the radius of that particular circle. Okay, so what is the observation we have made? For each and every circle, the distance measured from the center of the circle to the point 1 comma 0 represents radius of that particular circle. Understood? So for x is equal to 0, its center is 1 comma infinity. So from the center to 1 comma 0 represents the radius of x is equal to 0. For x is equal to 1 by 2 circle, its center is 1 comma 2. So the distance from this center to 1 comma 0 represents the radius of x is equal to 1 by 2 circle. So this is the observation we have made. Understood? So once you get familiar with these observations, then it is going to be very simple to draw these constant reactance circles on the gamma plane. Okay, so okay, fine. Okay, so first we try to represent this x is equal to 0 circle. So its center is at what here? Its center is at 1 comma infinity and radius is what? Radius is infinity. Okay, okay. So now here, okay, so on this line, so this is 1 comma 0. So the center of the circle is 1 comma infinity. So somewhere here. So if you go up to infinite distance, so somewhere here the point is 1 comma infinity. So this point is 1 comma infinity. Okay. Now we are trying to draw x is equal to 0 circle here. Okay. For that circle, the center is at 1 comma infinity. Understood? And the distance from 1 comma infinity to 1 comma 0, the distance from 1 comma infinity to 1 comma 0 represents what? Represents radius. That's what the observation we have made or not? That's what the observation we have made here. The distance from the center to 1 comma 0 represents the radius. Okay, so the distance from 1 comma infinity to 1 comma 0 represents the radius, and its length is how much here? The length of this radius is how much? Is equal to infinity. Yes or no? Okay, so its radius is equal to infinity. So now with this infinite radius, if you try to draw a circle here, what you are going to get here? You are going to get a straight line. Yes or no? So if you try to draw a circle with infinite radius, then it will never take a curved path here. So you are going to get what? You are going to get simply a straight line. Understood? Okay, so with this infinite radius from here to here, the radius is infinity. So with this infinite radius, if you try to draw a circle, it will never take a curved path. So it is going to trace along this, it is going to trace this straight line. Okay, so with this infinite radius, if you try to draw a circle, you are going to get what? You are going to get a straight line. You are going to get a straight line along this u axis. You are going to get a straight line along this u axis. Okay, so this u axis itself represents what? Represents x is equal to 0 circle. X is equal to 0 circle. So x is equal to 0 circle is the circle with the center 1 comma infinity and radius as infinity. Okay, so if you try to draw the circle with infinite radius, we are going to get what? We are going to get a straight line. Understood? Okay. Okay, so we have successfully mapped x is equal to 0 circle. Okay, next. Okay, next we try to map x is equal to 1 by 2 circle. Its center is 1 comma 2 and radius is what here? 2. Okay, so center is 1 comma 2. So somewhere here. So let us say this point is 1 comma 2. This point is 1 comma 2. Okay, so the distance from the center to 1 comma 0 represents the radius of that circle. Yes or no? So with this radius we have to draw the circle. So we will get the circle like this. Okay, something like this. Understood? Okay, so the distance from here to here, is how much here? 2. This represents the radius. The distance from here to here is 2. This represents the radius of the circle. Understood? Okay. Okay, so this circle is constant reactance circle. Yes or no? So what is the reactance value on this circle is 1 by 2. So this represents x is equal to 1 by 2 circle. Okay, so next we try to represent x is equal to 1 circle. Its center is what here? 1 comma 1 and radius is what? 1. Okay, so let us say this point. This point is, let us say this point is 1 comma 1. Let us say this point is 1 comma 1. So the distance from the center to 1 comma 0 represents what? Radius. Okay, so with this radius we have to draw the circle. See, the distance from here to here, the distance from imaginary axis, the distance from this ZV axis to this line, the distance from here to here, is also what? Is also 1 or not? Okay, so this also represents what? Radius is equal to 1. So the distance from here to here is radius is equal to 1. Okay, so it has to touch this imaginary axis at this point. Okay, and the distance from here to here is how much here? 1. So that means it also represents what? Radius. So from here to here, this circle must have the radius 2, but this circle must have the radius 1. Sir, no. Okay. Okay, so this circle is x is equal to 1 circle. So on this circle, the value of reactance is how much here? 1. Understood? So it is touching, x is equal to 1 circle is touching the imaginary axis, at which point here? At 0 comma 1. Understood? Okay, so this is x is equal to 1 circle. So like that, in that manner, if you try to represent x is equal to 2 circle here, its center will become 1 comma 1 by 2 somewhere here. Okay, and its radius is 1 by 2. The distance from here to here will become 1 by 2. Then with this radius you have to draw the circle. Okay, so I am drawing roughly here. The diagrams. So let us consider this as x is equal to what? This is x is equal to 1 by 2. Okay, see, as x value goes on increases, its radius goes on decreases, and the center will shift from 1 comma infinity to 1 comma 0. Understood? So as x value goes on increases, the radius of these circles is going to decrease. So for, let us say, this is for x is equal to, sorry, this is x is equal to 1 and this is for x is equal to 2f. Sorry. This is for x is equal to 2 and let us say this is x is equal to 4 or something. Okay, so like that, if you go on increase the x value, the radius of these circles goes on decreases. So you will get the circles like this. Okay, so now at x equal to infinity, the center will become 1 comma 0 and radius will become what? 0. So that means this point 1 comma 0 point, this 1 comma 0 point. So this point represents what? Represents x is equal to infinity. So x is equal to infinity represents what here? Point circle. It represents point circle. Understood? Okay, fine. So we have mapped all the possible values of reactances onto the gamma plane. So from x is equal to 0 to x is equal to infinity. For x is equal to 0, the center is at 1 comma infinity. And radius is infinity. Okay. Next, as x goes on increases, as x value goes on increases, the radius of this circle gradually decreases and the center will shift from 1 comma infinity to 1 comma 0. 1 comma infinity is somewhere here, and from 1 comma infinity the center shift to 1 comma 0. Yes or no? Okay, so we can draw some more circles here if you want. So you can draw the circle here. See, this radius is greater than x is equal to 1 by 2 circle. That means this value, this x can be something. You can take 1 by 4. So as x value goes on decreases, the radius of the circle is going to increase, and when x is equal to 0, its radius will become infinity. Understood? Okay, so like that you can draw some more circles like this. Understood? So all this represents what are constant reactance circles. Okay, now there is no need to do the detailed analysis in order to represent the negative reactance circle here. Okay, you can just make a note. That all the negative reactance circles are mirror images of positive reactance circles. Okay, so if you try to draw the negative reactance circles, you are going to get, extend this line here. So the centers of all the negative reactance circles are going to lie on this line. Okay, so now try to draw the negative reactance circles. You are going to get the circles like this. Okay, so you are going to get the circles like this. So now this circle that is touching the imaginary axis, at this location, this represents what? This is the mirror image. Of this circle. Here this is the circle that is touching the imaginary axis. Yes or no? So here this is the circle that is touching the imaginary axis at this point. So this point is 0 comma minus 1. So this represents x is equal to 1 circle. So this represents what here? This represents x is equal to minus 1 circle. Okay, you just draw the mirror images of positive reactance circles. Then you are going to get what? Negative reactance circles. And the centers of all the negative reactance circles are going to lie on this line. You just extend this line. You take the mirror image of this line here. You are going to get this one. Okay, so it can go up to what? This will go up to 1 comma minus infinity. Understood? Okay, so now we try to write the characteristics. of the constant reactance circles. So next we will write the characteristics of constant reactance circles. Okay, so next we will write the characteristics of constant reactance circles. See the first point. Now if you observe, all the positive reactance circles are present above the u-axis, and all the negative reactance circles are present below the u-axis, and these negative reactance circles are the mirror images of positive reactance circles. Understood? Okay, and positive reactance circle, reactance is positive means it represents what here? Inductive nature. And if the reactance is negative means what here? It represents what? Capacitive nature. So first point we are going to write like this. Okay, so all the positive reactance circles, in brackets, inductive in nature, are present above the u-axis, and all the negative reactance circles capacitive in nature are and all the negative reactance circles are mirror images of positive reactance circles, and hence these are present below what? Below u-axis. Okay, so this is the first point. All the positive reactance circles which are inductive in nature are present above the u-axis, and all the negative reactance circles that is in capacitive in nature are mirror images of positive reactance circles, and hence these are present below the u-axis. Okay, right, the second point. Okay, so if you consider all the positive reactance circles within the range 0 to 1. I am not including 0 and I am not including 1. Okay, if you consider all the positive reactance circles between 0 and 1, not including 0 and not including 1. Okay, so then if you observe these reactance circles here within this range, okay, so here see x is equal to 1, this is the circle, yes or no? This is the x is equal to 1 circle. Now as x goes on increases here, okay, so these circles, these constant reactance circles are lying in which quadrant here? Are lying in only first quadrant. So that means if x value is greater than or equal to 1, all the constant reactance circles are passing through only first quadrant. Yes or no? Now if you consider the reactance value between 0 to 1, okay, so then you are going to get all these reactance circles. Yes or no? All these reactance circles. So if it is less than 1 here, if the reactance value is less than 1, then all the reactance circles are passing through what here? First quadrant and second quadrant. If x is greater than 1, okay, then it is going to pass through first quadrant. If x is less than 1, then they are going to pass through first quadrant and second quadrant. Understood? Okay, so here you can write the second point. So all the positive reactance circles, all the positive reactance circles, all the positive reactance circles within the range, within the range, within the range of 0 to 1. I am not including 0 and I am not including 1. Okay, so within this range are passing through what here? Are passing through both 1 and 2 quadrants, are passing through both 1 and 2 quadrants. Yes or no? Okay. Next, in the same point here, in the same point I am writing all the positive reactance circles, all the positive reactance circles within the range, within the range of 1 to infinity. 1 to infinity. I am including 1, but I am not including infinity. Okay, so 1 to infinity are passing through what? Are passing through only first quadrant. Yes or no? Are passing through only first quadrant. So if x is varying between 0 to 1, if x is varying between 0 to 1, all the constant react, and I am not including 0 and I am not including 1. Okay, so within this range, all the positive reactance circles are passing through both first quadrant and second quadrant. So once x becomes greater than or equal to 1, once x becomes greater than or equal to 1, then it once x becomes greater than or equal to 1, then for x greater than or equal to 1, all the circles are passing through what? Are passing through only first quadrant. Understood? So that's what we have written here. Okay, so under this second point here, under this second point, we can write a note. Okay, so under that note, we will write for negative reactance circles here. So within this same second point, we are going to write a note. Okay, so in this note, we will write for negative reactance circles here. Understood? Okay. So here x is equal to minus 1. Now here this circle is x is equal to minus 1. Now if you vary x between minus 1 and 0, between minus 1 and 0, then all these negative reactance circles are passing through what here? Are passing through third and fourth quadrants. Yes or no? I am not including minus 1 and I am not including 0. Between this range, minus 1 to 0. Okay, all the negative reactance circles are passing through what? Are passing through third and fourth quadrants. Okay, so here we can write all the negative reactance circles, all the negative reactance circles within the range of minus 1 to 0. I am not including minus 1 and I am not including 0. So within this range from minus 1 to 0. Okay, within this range, all the negative reactance circles are passing through what? Third quadrant and fourth quadrant. So this is third quadrant and this is fourth quadrant. Okay, so range of minus 1 to 0 are passing through 3 and 4 quadrants. 3 and 4 quadrants. Yes or no? Okay. Next, all the negative circles in the same point here. All the negative reactance circles. All the negative reactance circles within the range of. Okay. Now see here. Now here this point. So at this point, whether x is equal to, at this point x is equal to plus or minus what? Plus or minus infinity. Whether x is equal to plus infinity or x is equal to minus infinity, the radius of the circle will become what? The radius of the circle will become 0. Yes or no? That means it represents a point circle at point 1 comma 0. This point is nothing but what? 1 comma 0 point. If you consider the x values, within the range of minus infinity to minus 1 here. Minus infinity means this point. Okay, so from minus infinity to minus 1, all the negative reactance circles are passing through only what? Are lying in only 4th quadrant. Understood? Okay, so all the negative reactance circles within the range of minus infinity to minus 1. I am not including minus infinity here, I am including minus 1. Okay, so within this range are passing through what? Are passing through only 4th quadrant. Are passing through only 4th quadrant. Are passing through only 4th quadrant. Okay, understood? So as x value varies from minus infinity to minus 1, all these negative reactance circles are lying in 4th quadrant. And as x varying from minus 1 to 0, okay, in between minus 1 to 0, all the negative reactance circles are passing through 3 and 4 quadrants. So that's what we have written here. Understood? Okay, so 2 points completed here. Under the second point, we have written the node for negative reactance circles. Understood? Okay. Next, we will write third point. Okay. So third point. See. Now as x value varies from 0 to infinity. Yes or no? As x varies from 0 to infinity. At this location x value is infinity, and at this location x is equal to 0. So as x varies from 0 to infinity, the centers of the circle are shifting from where to where? 1 comma infinity to 1 comma 0. Yes or no? For x is equal to 0, what is the center? 1 comma infinity. Yes or no? For x is equal to infinity, what is the center? Is nothing but 1 comma 0. So that means as x varies from 0 to infinity, the center of the circles are shifting from where to where? From 1 comma infinity to 1 comma 0. Okay. So, and what happens to the radius here? Radius is varying from infinity to 0. For x is equal to 0, the radius will be infinity, and for x is equal to infinity, the radius will be 0. Understood? Okay. So we can write that point. So that is as x varies from 0 to infinity, the centers of the circles shift from where to where? Shift from, or you can write move from. Okay, move from 1 comma infinity, shift from 1 comma infinity to 1 comma 0. So at x is equal to 0, the center will be at 1 comma infinity, and x is equal to infinity, the center will be at 1 comma 0. And radius varies from infinity to 0, and the radius will vary from infinity to 0. When x is equal to 0, the radius will be infinity, and when x is equal to infinity, the radius will be 0. Understood? Okay. So here we will write a note here. So in this note, we will write for negative reactance circles. Okay. So vary the x value from minus infinity to 0. So as x varies from minus infinity to 0, the center will shift from where to where? The center will shift from 1 comma 0. The center will shift from 1 comma 0 to 1 comma minus infinity. Yes or no? Okay. So here as x varies here, as x varies from minus infinity to 0 minus infinity to 0 minus, as x varies from minus infinity to 0 minus. 0 minus means what here? It is the nearest negative value to 0. Understood? Okay. The centers of all the, see, minus infinity to 0 minus means we are considering the negative reactances. So the centers of all the circles shifts from, so when x is equal to minus infinity, the center is at what? The center is at 1 comma 0. Yes or no? Shifts from 1 comma 0 to, when x reaches to 0 minus, that is the closest negative value to 0, then the radius will, then the center will move to what? Move to 1 comma minus infinity. Okay. So the circle shifts from 1 comma 0 to 1 comma minus infinity. 1 comma minus infinity. Okay. And what happens to the radius here? And the radius varies from, then always radius you have to consider as positive value. Okay. So whenever x is equal to minus infinity, radius is nothing but what? 1 by x. So you are going to get 0. Okay. So the radius varies from 0 to what? The radius varies from 0 to, whenever x is equal to 0, the radius will go up to infinity. You have to consider always positive value for radius. Okay. Radius varies from 0 to infinity. Understood? Okay. So this is the third point we can write. Okay, fine. So now we will write the fourth point. Okay. See, for x is equal to 0, the center is at what here? The center is at 1 comma infinity. That means I can say, if you consider x is equal to 0 plus, so that means it is the closest positive value or the nearest positive value to 0. Okay. So that means if you consider x is equal to 0 plus, just slightly positive, then the center will tends to what here? The center will tends to 1 comma infinity. Yes or no? Okay. So if you consider x is equal to 0 minus here, this is the closest negative value to 0, then the center will go to what? The center will go to 1 comma minus infinity. So I can say for x is equal to 0, the center can be at 1 comma plus or minus infinity. So for x is equal to 0 plus, it will go to 1 comma infinity. For x is equal to 0 minus, it will go to 1 comma minus infinity. Okay. So I can say for x is equal to 0, the center is at 1 comma plus or minus infinity. Yes or no? Okay. Just for 0 plus, the center will go to 1 comma infinity. Just for 0 minus, the center will go to 1 comma minus infinity. Understood? Okay. Okay. So x is equal to 0. Represents a circle whose center is at 1 comma plus or minus infinity. So in brackets, if you want, you can write, that is for x is equal to, so in brackets you can write as x is equal to 0 plus, okay. So center will be at what? 1 comma infinity, and for x is equal to 0 plus here. and for x is equal to 0 minus, the center will be at what? 1 comma minus infinity. Okay, if you want you can write this in brackets. Okay, so x is equal to 0 represents a circle whose center is at 1 comma plus or minus infinity, and radius is what here? And radius is infinity, and radius is infinity, and hence it is called as circle with infinite radius. Circle with infinite radius. That is, it represents a straight line. It represents a straight line along u axis. Understood? Okay, so x is equal to 0 represents a circle whose center is at 1 comma plus or minus infinity. If you consider x is equal to 0 plus, the center will be at 1 comma infinity, and the distance from 1 comma infinity to 1 comma 0 is 0 represents radius. With that infinite radius, if you try to draw a circle, you are going to get a straight line. Or if you consider x is equal to 0 minus, the center will shift to what? 1 comma minus infinity, and the distance from 1 comma minus infinity to 1 comma 0 is also infinity. Yes or no? So with this infinite radius, if you try to draw a circle, you are going to get what? You are going to get this straight line on the u axis. Understood? So I can say simply, for x is equal to 0, the center is at 1 comma plus or minus infinity. So for x is equal to 0 plus, it is at 1 comma infinity. For x is equal to 0 minus, it is at 1 comma minus infinity. And its radius is what here? And its radius is infinity. And hence it is called as what? It is called as a circle with infinite radius. So a circle with infinite radius always represents what? Always represents a straight line. Okay, now here we will get a straight line along what? Along u axis. Understood? Okay, so this is the 4th point. Okay, so next we'll write 5th point. Now we'll write x is equal to 1 here. Okay, see, x is equal to 1 is the only circle that is passing through what? That is passing through 0 comma 1. Okay, so I can write here x is equal to 1 is the only circle that is passing through what? That is passing through 1 comma 0. Sorry, that is passing through 0 comma 1. That is passing through 0 comma 1. So here you can write a note. That is passing through 0 comma 1. Okay, so you can write a note here. X is equal to minus 1. X is equal to minus 1 is the only circle. Passing through. X is equal to minus 1 will pass through what? X is equal to minus 1 circle. It is passing through what? 0 comma minus 1. So through 0 comma minus 1 is the only circle passing through 0 comma minus 1. So write down this as 5th point. We have written for x equal to 0. Next we have written for x is equal to 1 and x is equal to minus 1. Next we will write for x is equal to plus or minus infinity. Okay, so the 6th point. So for x is equal to plus or minus infinity represents what here? Represents a point circle. At the point 1 comma 0. So this 1 comma 0 point represents the point circle. Understood? Okay, so that is the 6th point. Okay, next. So next, if you consider this u axis here, okay, see, it is acting as a common tangent to all the positive reactance circles and also for all the negative reactance circles. Yes or no? So it is acting like a tangent. Understood? Okay. So 7th point I am writing this. Okay. So u-axis is acting as common tangent. Is acting as common tangent to all the reactance circles. It may be positive or it may be negative. Okay, to all the reactance circles, u-axis is acting as what? Is acting as common tangent to all the reactance circles at point. Where it is acting as tangent here? At point 1, 0. At point 1, 0. Okay, so u-axis is acting as what? Is acting as common tangent to all the reactance circles at point what? At point 1, 0. So at point 1, 0. Okay, so this u-axis is acting as a tangent to all the positive reactance circles and also to all the negative reactance circles, and hence I have simply represented here as all the reactances. That includes both positive as well as negative reactance circles. Understood? Okay, so these are the characteristics. Of this constant reactance circles. Understood? So we have successfully mapped all the possible values of reactances onto the gamma plane. Okay, so next we are going to superimpose all the possible values of resistances and all the possible values of reactances. Okay, so that is going to give you all the possible values of load impedances. Okay, so next what we are going to do is we are going to superimpose all these resistance circles and reactance circles onto the gamma plane within a unit circle. Then that forms or that completes the development of Smith chart. Understood? So we are going to see that in the next lecture. Until then, bye bye, tata, see you, enjoy. Okay.